So we're going to be talking about imaginary numbers and complex numbers. The first thing that you need to know about imaginary numbers is for an imaginary, we use I is equal to the square root of -1. So an imaginary number is defined as a number whose square is the -1. Okay? And so these are numbers where we said that there were no real solutions. You guys have dealt with imaginary numbers before. You had things like in Algebra 2 where you had x squared is equal to -9, and you took the square root of each side, and you said, okay, it's square root of -9, and you said no real solutions. Well, -9 is actually imaginary. Okay? Because all imaginary is just a different number line. Okay? It's not going to be on the regular coordinate plane. So we'll talk about that a little bit later on. Okay? And we'll elaborate on that. So imaginary and real numbers together make up the set of what are called complex numbers. And so a complex number is any number of the form. So you have a plus bi, or bi plus a, or a and b are real numbers. So a complex number has two parts. You have this part, the number that doesn't have the I next to it. That's actually going to be the real part. And bi, the one with the I next to it, that's actually going to be the imaginary part. Okay? So, if you had a good grasp of simplifying radicals, which we did earlier, if you watched the earlier video, then you'll be okay with simplifying these radicals involving complex numbers. So we already went through when you simplify a radical, you break it down into its roots, okay? And then you take double dap. We're going to just add a little twist right here with imaginary roots, okay? So for this one right here, this is the square root. I'm going to rewrite this as -1 times 2, and I'm going to break it apart. I'm actually going to take that -1 and I'm going to set it out on the outside. Okay? So, for this right here, I can't simplify 2. There's no doubles in here. I can't simplify it anymore, so I just leave my square root of 2. Here, I just change this. This right here, we just rewrite this as the letter I for imaginary, and that's actually your final answer. All you're going to do, the only thing that's different from when you simplified radicals before is for any time you have a radical -1, you're going to replace it with I. So number 2 here, I set this to a side, and I rewrite this part right here. So this part right here, this is the square root of -1 times the square root of 8. Now 8 we can simplify, okay? And I'm going to do my prime factorization. You're always welcome to do your factor tree. So 8 divided by 2 is 4. Well, 4 I can break down. Like 4 I can divide by 2, and I get 2. 2 I can break down to be 1, okay? So 8 is 2 times 2 times 2. Okay, so remember that that is all underneath the square root. So I know I can take the square root of this right here. So this is going to be 2. Okay, so this is just a 2 coming down. This 2 right here, I have a 2 on the outside. This right here, I rewrite as the letter I. And do I have anything left over that does not have a double? Well, yeah, I have a 2 here. So this is going to be radical 2. So this is going to be 4i radical 2, and that is your final answer. Number 3, you actually have no imaginary, so this one you just have to break it down. I'm just going to bring this 2 down. 48 divided by 2 is 24. 24 divided by 2 is 12. 12 divided by divided by 2, I can divide it by 3, and I get 1. Okay, so I take those out. Okay, so I can take out a 2 here. I can take out a 2 here. And I'm left with a 3. The 3 has no doubles. The 3 I can't take a square root of, so I leave a 3 in here. 2 times 2 is 4. 4 times 2 is 8. And so your answer right here is 8, radical 3. Number 4 here, I do have imaginaries. You know you have imaginaries when you have this negative on the inside underneath the radical. The 4, I simply break down. I know I have a negative 1, and then I have a radical 50. Now the 50, I break down. 50, I can divide by 2. That's going to be 25. Now I think about my next number, so if I can divide by 2. Now if I'm done dividing by 2, or it can't be divided by 2, then I go to 3. Well, 3 doesn't go into 25. So then I go to my next prime number. That's going to be 5. Okay? 25 divided by 5 is 5. 5 divided by 5 is 1. I look at this right here. I have a pair of 5s, and then I have a 2 alone. So I rewrite this. I have my 4 here. This 5. Okay, I take a 5 out. This, I just rewrite as the letter I. Just tells me that there was a negative radical 1. It was imaginary. And then what I have left in the inside is 2. So it was 20i radical 2. That is your answer to that one. Just try these last 3, and then we'll be done. Hopefully that'll help. Okay, so negative radical 98. This is not going to be imaginary. This is going to be real because the negative is not underneath. So I'm just going to put a 1 there, and I'm going to bring it down. So I have a negative 1, and now I break down 98. 98 divided by 2 is 49. Now I go through. 3 doesn't go into 49. 5 doesn't go into 49. 7 goes into 49 7 times. 7 and 1. So 98, I can break it down. I take the 7 out of here, because the square root of 49 is 7, and what I'm left with is 2 doesn't have a date, 2 stays in, so this is negative 7 radical 2. For number 6, this one right here is also not imaginary. You just carry this down. Negative 3. Okay, now 24. 24 divided by 2 is 12. 12 divided by 2 is 6. 6 divided by 2 you get 3. 3 divided by 3 is 1. And so I can take a 2 out, because that has a pair, and I'm left with a 2 and a 3 on the inside. All of it is multiplication. So my answer is negative 6 radical 6. Okay, just 2 more to go. These 2 have imaginary because there's a negative radical, or there's a negative underneath the radical symbol. So I'm going to rewrite this. This is going to be negative 1 times negative radical 1 times negative radical 9. Okay, you guys should know that the square root of 9 is 3, and square root of negative 1 I just rewrite as I. To rewrite it properly, I just rewrite it as 3i. Okay, and my very last question. This is radical negative 32. I rewrite it. I have a negative 1, so I take that out, and I have a radical 32. Now 32 can be broken down. 32 divided by 2 is 16. 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2. 2 divided by 2 is 1. So I know that I'm going to have my I here. I know I'm taking a 2 out here, and then a second 2 out here, and I have a 2 left in my radical. 2 times 2 is 4.
All students riding the after-school activity bus should make their way to door 17. All students riding the after-school activity bus may